Good morning, class. Today we're going to be talking about classes and objects. So up to this point, we've talked about encapsulation. We've seen some examples of encapsulation using structs, and a class is very similar to a struct. So let's go ahead and look at this program, and then we'll see how we can actually use classes to help simplify while also complexifying it, if that makes any sense at all. So we have a very simple imperative style of program where we're basically just doing one step-by-step thing, and in very classic imperative style, we're just declaring variables. So for example, this is to split up bills amongst roommates. So we set a variable of how many roommates we have. We set an array of all the amounts of the bills that we're dealing with. And then we have a amount due, and we're using decimals for these values. Decimals in C# are fixed point decimal numbers. They're appropriate for use with currency where we really need to avoid floating point error. And then we're going to just iterate over all the bill amounts and add those into that total due, and then print out the result of taking that total due, dividing by the number of roommates, so the average of all the bills across the number of roommates, so everybody pays the same share. If we go ahead and run this, you can see we print out the command line, each roommate's share is going to be $80. And we might throw a dollar sign in here just to make that clear that we're working with US dollars. And that's a very simple imperative approach. And this works well for small programs, but as programs get larger and larger, it becomes harder to kind of track these things. Another thing is all of our values here are hard coded, so you would have to come in and alter this program every month, put in the new bill values, run it again. And you might not want to have to compile it every month. You might want to just be able to drop this as an executable on your desktop and be able to enter the values through a GUI. Or you might put this behind a web server and then be able to input the values of the different bills monthly, and you might want to store those values as well, so be able to go back and look at old bills and see how much they are. All of that kind of functionality is where object orientation really starts to shine, because that's where we can bring in a lot more detail. So let's go ahead and think about what we need to represent this particular problem space as an object-oriented program. Well, we really have two things we're dealing with: bills and roommates. So we'd want classes for those two things. So let's go ahead and add a bill class first. And what kind of information do we need in a bill? First of all, we're going to make it public. That way this can be used in other parts of our program. We can actually create instances of this class elsewhere outside of this class. It's very rare that we would want to have a private class. There are some situations where we would, but by large, and at this point in your computing career, every class definition is going to probably be public. So what would we need? Well, we need maybe a string for the name of the bill, and we would need a amount, which is going to be a decimal telling us how much is due, and we might want like a public date, time, due date, because we might care about when that bill is actually coming due, so we can make sure that we pay it before that due date. That might be important. And maybe some other information. There's the account number we could add. Let's go ahead and throw that in. Public string account number. And I use a string in this case because account numbers sometimes have letters in them or hyphens or other special punctuation we might want to maintain. So a string is an easy way of doing that. Okay, now at this point, this looks a lot like a struct. And we could almost say the two are interchangeable, but they're not. A struct is a value type. That means that when we declare a variable of that type, we actually hollow out a chunk of memory to hold those. That is right there. That variable actually directly holds that value. So it basically holds all of a reference to a string, because strings are reference types, and then it has enough bits to hold an amount due that's a decimal, and enough bits to hold the date, which is a struct. Date time is a struct as well, and then another reference to a string, which is stored elsewhere in memory, because the strings can be any amount of length. If we wanted them to be fixed, we'd probably use a character array instead. But that's the struct way. But with a class, we're actually declaring an address of where that class is stored in memory elsewhere. So it actually gets stored elsewhere, and we'll talk about that a little bit further along the line in the textbook. But they are stored slightly differently, and that has some important implications as we program with them. And the other thing we need to do here is we need to update this to be a bill instead of a decimal, which means these values no longer quite fit. And to be quick and dirty, well, actually, if we want this to be variable, let's go ahead and use a list. And though list is declared, or at least the generic list, which is what we prefer to use here, is declared in the system collections generic namespace. So let's make this a list of type bill, and we're just going to call it bills now. We'll set that to be a new list of type bill. Now C# has introduced a lot of ways to kind of optimize our typing, make this less amount of typing that we need to do. So you will sometimes see people do this, where they just declare a variable. This variable still has the type list bill, but now it's inferred by looking at what we're constructing. So it is still technically a list of bills. It's just we use this shorthand to say I'm not going to tell you what it is. It just needs to be a variable of whatever type I throw in it the first time. This variable cannot change. This is still a static variable. In other programming languages like Python, which you've played with, those are dynamic and you could actually put anything in a var. Here we actually still define what it is based on the first time we set it. There's also a newer syntax that came out in C# 7 or 8, where you don't have to repeat the type when you're invoking the constructor. You can just do new parentheses and say, go ahead and create an object of whatever type this was. And that's fine too. You'll see those in practice, so I want to show those to you now. And in fact, you can see it's suggesting that we can simplify that new expression exactly like we just did. But if you want to make it as old school and legible as you can, go ahead and just spell it out like this. I don't have a strong preference as to which you're using, but I want you to be familiar with both because you will see both in practice. Actually, all three of those methods I just showed you. Okay, and then we'd need to declare the individual bills. So maybe our first one is our gas bill, and so we'd say the gas.name is going to be gas bill, or maybe you'd use Westar, whatever service you have, and gas.amount due is going to be that first amount, that 140.27, and we throw this im on to basically indicate that this is intended to be a decimal. It's a literal decimal, not a literal float, which is what it will default to without the im. If you take the im off, you notice it's telling us that we're trying to convert a float into a decimal, and it doesn't want to do that because it risks losing precision when you do that. So we have to tell it, no, actually this is meant to be a decimal. Go ahead and use it this way. And then we could add the account number and the other details. But let's go ahead and move on to our next one. Bill gas and bill electricity. And we'll call this electric bill, and electric amount due, and we'll set that to our next amount, which was 145.12, and then and again the im there. Now C# as it's evolved over time, has added a lot of ways of simplifying syntax to make it faster for programmers to write their programs. So that omitting the constructor type that I showed you before, that's one of those. Another is how we actually instantiate classes. One of the possible ways we can do it is we use an instantiation syntax, which is very similar to how we created that array where we just put the values in curly braces. And we can do that here. And how that works is instead of having our semicolon, we go ahead and open a scope with the curly braces. We throw our semicolon down there, and we put these arguments in here. But we no longer need to identify with electric dot because we're setting the name property of electric already. So it knows that this name goes to this variable because it's inside this initialization syntax. And then we just go ahead and set the property equal to whatever value it is. And then instead of semicolons, we're going to use a comma delineated list. So the next one would come on the next line, and we say the amount due is going to be this amount. And then we can either have a trailing comma or we can omit the trailing comma. So depending on if you want that or not. Normal English, we often will omit that comma, and there's a whole debate on if it's better to have the comma or not have the comma, depending on where you learned how to write, but it's pretty standard that we leave that off. Some programming languages, when they use this style of syntax, will enforce that comma can't be there. C# will accept it either way. So that's you can see a more streamlined way of basically setting these same things. We could take that one step farther with, let's create a bill for the next one, this 84. We're going to make that be cable and internet. So we could just, again, do new. We don't necessarily have to have bill there because the bill can be inferred from here. So if we're using that newer syntax, and be aware that that is new syntax. So if you're targeting an old version of C#, which when you get out into the world you may be maintaining older programs, that won't work with an older version of C#, so it won't compile. So be aware some of these syntactic sugar, is what we call them, new ways of writing the same idea, aren't necessarily going to be always available to you, depending on what version you're working with. So again, name, and we'll call this cable and internet. And the amount due is going to be our 84.21 M, and put our semicolon there. So you can see we're getting less and less typing involved. And then our last bill, let's call this water, new, and we'll just use that same abbreviated style. The water bill, and that probably is City of Manhattan or something like that. And the amount due is going to be 30.40 M. Okay, and now we have all of that same information in there. And instead of iterating through the bill amounts, now we can iterate through the bills. Obviously, these are going to be bills, so we'll change this to a bill. And then it's bill.amount due. We'll access the amount due that we're interested in. So if we go ahead and run this, we can see each roommate's share is coming up as 0, which is interesting. Let's make sure that we've set these correctly. Amount due. And public class. So we create, why that is happening is we have this list of bills, which starts as an empty list. We create all these bills, but we haven't added them to the list. So bills.add, and we'll go ahead and add water, bills.add, cable, bills.add, electric, and bills.add gas. And I just added them in the reverse order. So now when we iterate, instead of iterating over an empty list, we're going to iterate over a populated list with our bills. And you can see we're still calculating the $80. So now we have encapsulated that within this bill class. And this is still operating very much like a structure, the way we're using it. But that's not as far as we take the idea of classes and object orientation. Because in classes, we can also add the ability to embed behavior into the class. And one of the things we also bring into that idea is the idea of data hiding, that we want this data to be available, but we don't want it to mutate in an uncontrolled way. We only want to be able to mutate it in ways that make sense for that particular class. So, what do we mean by that? Well, let's look at these bills. let's say somewhere else in our program we access, say, the cable bill, and we do something to it that we probably shouldn't have, like cable dot amount due. Maybe we just set it to 0. Well, is that going to affect the bill that's put into this list? And the answer is, well, let's find out. Sure enough, our bill went down, our total bill amount due for each roommate, which means we're going to be shy the amount we need to actually cover the cable bill, because we were allowed to manipulate this outside of that class. So one of the first steps that was taken to fix this, which appears in Java, is make these guys private. And then create methods to set those and update those. So public void set name, and that would take in a value, string name, and then here we'd say name equal name. In fact, I'm going to change this to value. And public void get name, and that would return a string. And we're going to return that private variable. So now we're storing this in a private variable. We have a setter and a getter, which allow us to set and get that. And that means that obviously we can't set the name this way anymore. So we're going to comment these out. And we would instead invoke set name. And you probably did a ton of this in 200. And why would we want to do this? Well, that allows us to add, for example, some custom logic to make sure that when we do this, we're setting it to, for example, something that we want it to be. So we could, for example, here say if value the length is not 0, then we'll go ahead and set that name to the value. And actually we could do this as a one-liner and just drop it on the same line. So basically only set the name if it's not the empty string. So we're not allowed to set it to an empty string. Of course, that doesn't help the fact that we could start with an empty string, but where that really might make sense is with this amount due. If we made that be a private variable, and then wrote our getter and setter, get amount due, return amount due, and our setter for that would be public void set amount due and decimal value. And I need a parenthesis there because this is a method definition. Then I could add if amount due equals or is less than 0, then perhaps we want to throw an argument exception, which is not technically true because bills, you can sometimes have a credit if you overpaid the last month, but you can see this gives us the ability to throw an exception or refuse to set a value if it's a value that we don't accept. So there's lots of ways we can control how that value is being set once we start using setters and getters. The problem is we now have to do all of this extra rewriting of all this code, adding a lot more to invoke the setters and set them up the way that they need to be set up, and that's probably more work than we want to do. Ideally, we'd like to kind of keep the same streamlined syntax where we just set the name. And that's where C# properties come in. So in C#, a property is a way of combining this idea of having that simple access where you can assign a value with the equal sign, and you can access the value by just calling or putting the name into an expression, but you can also have the control that these methods of setters and getters give us. So instead of defining it this way with these two methods, in a property we just say public string name, so the same way we did with a field, but instead of just putting a semicolon there, we add brackets and we have a get and a set, optionally a set, and optionally a get. And what these do is the get takes whatever we would normally put in that get, and what goes in the set was whatever we would normally put in the set. So we can put that logic for setting the value here, and notice that this value that we had as a parameter coming in, when we use a C# setter, it always receives a parameter called value, which is of the type of the property, which is what you've assigned the value to be. So if I jump back here and I had name equals gas bill like we do here, this is going to be the value coming into that setter, the gas bill string. So that is what comes in as this value that we can set, and now we can control if it's an empty string. And we can do the same thing for the get. We just return from that whatever value we're pulling out. So this one out of the get name. So this is a abbreviated way of writing getters and setters called a property in C#. It's a C# language feature that doesn't exist in other languages. Now other languages have added their own ways of doing getters and setters, or accessors is kind of the blanket term that covers those, because they are so handy. And it just makes a lot of sense because that's something that we always end up doing. So we can do the same thing on our amount due. So we have a private variable, we can have a public property that accesses that, where we call it amount due, and then we write our getter. So our get method is basically, our setter is basically this method, and our getter is basically this method. So we replace that get amount due with the keyword get, and we tab this whole thing over. And notice it doesn't matter if I put the setter or getter first. Here I have get first and then set. Here I have set and get. It's perfectly fine to do it either way, but conventionally we usually put the getter in front of the setter. And then there are, again, more abbreviations. If we don't need to do any kind of validation or anything in the setter or getter, any kind of extra calculation, we can actually go ahead and use what's called auto property syntax, where we just say get set, and we tell the compiler I want a getter, I want a setter, I want a field to put that into, so this private backing field, and in this case the compiler creates one for us and populates it for us, which is really handy because now we really can minimize the amount of code we have to write to get the effect we want. So these are semantically equivalent to having a getter and a setter where there's no extra logic, just the returning of the private variable and the setting of the private variable. But notice that we haven't defined a private variable for these, so it's not accessible. It's one that actually gets created at compile time. It's given a name by the compiler, which we can't access directly in our code, because when we compile our code, it doesn't exist yet. It doesn't exist until the compilation process is completed. So we don't have a name to access it by. Alright, so if we save that and come back over here, now we don't have to do these setters. We can uncomment setting the name, and setting the name in all these different ways, which we still do like we did with a field, will just work. Alright, so if we go ahead and run this, we should get back to our share. Now we're still manipulating that amount due, and I'm going to come back and talk about that in a moment. But we can also do change the name, and let's try setting this to an empty string. And if we're able to set that to an empty string, well, in order to see that, let's go ahead and print in our for each console dot write line, and let's print the information about our bill. Bill.name is for bill.amount due. And if we were able to set that name to be the empty string, then this should be empty string is for, so we shouldn't have a name. Run that. And notice that, oh, we were able to do that. So let's go back, and I bet you value.length. That's interesting. So if it's not an empty string, let's try that again. Still resetting that. Cable, actually that was the second one. So actually, it's not resetting. What's going on is we didn't actually put a value in for the electric bill, so the electric bill starts out as an empty string and just stays an empty string. So now, notice we have all the values, even though we tried to overwrite the amount due here. So we've added that extra control. Or if we made the cable be a -10, remember we made it throw an error if we try to do negative values. So if we try running that again, did I comment that one out? Let's see, bill amount due is less than 0. Oh, because I'm checking the amount due and not the value that's coming in that we're trying to set it to. So value should be less than 0. So if we try doing that, there's our exception. So we did something that crashed the program because we threw an exception. We're not catching it anywhere. So obviously we're now controlling these to a certain degree. Now with a bill, ideally we'd want to set these once and never have them change, right? Because the bill's not going to change its value. So instead of doing get and set, what we could do is have set only properties. So just delete our getters. Now this is effectively read only because, oh, other way around. Delete our setters. Because we can only get those. Now this, actually I'm going to leave the auto ones alone for right now. So let's go ahead and just do these ones with private backing fields. So if I were to run that again, now we're going to have a build error because we can't set these anymore because there's no setter. So the traditional way of doing kind of this set only thing is to add a constructor to our bill. So that is a special method which has no return type because it's a constructor. It has the same name as the class, so bill, and then takes parameters. So in this case, we'll take a string for the name and a decimal for the price or amount due. And then we can go ahead and set those private backing fields of amount due to be the amount due and the name to be the name. So now when we construct it, we specify what those are, and then after that point they can no longer be changed. So if we come back in here, since these are now constructor arguments, instead of doing gas.name like that, we would say gas bill is our first argument and amount due, the amount due, is our second argument. And these are going to be set to those properties. And we can do the same thing here. So these are going to be now coming in as parameters on the constructor. So this is another way of populating those values. But notice that's going to cause problems with our cable and our water bill. We need to add those in as well. So yeah, let's just go ahead and do it for all of these. Actually, for now, I'm just going to comment those out because we're going to come back and do something a little bit different with those, which means water and cable we're not going to add here. And I'm going to try, let's change, let's try doing this name set with the gas bill. So notice that it's not going to allow us to do this because that's now a get only property. And the same thing if we try gas.amountDue. It's not going to allow us to do that because amountDue is a get only property, which makes it read only. So we can't even write code to do that thing now. So now we've protected ourselves from having these mutate unexpectedly. So we go ahead and run this again. And we're going to get the two bills that we left in and the average of those two bills. Okay, but what if we want to keep using this initialization syntax and we do want to be able to initialize these but not change them after that? There is another accessor method that was added to C#, which is called init, which is like a setter, but it can only be called once and only within an initializer statement. So we'd say, in this case, name equals value. And we can do the same thing down here with the amount due. Init amount due equals value. So this is like a setter, but can only be called from within an initializer, which is what these guys are. So if I take out these comments, that should... the other thing is our constructor still is expecting those. So we can add another constructor, an override constructor, public bill, or an overload, that doesn't really do anything. It takes no arguments, does no extra work. If we have no constructor in our class at all, which is where we started, the compiler will actually give us a constructor that looks just like this. It will add that one in, and that's the default constructor. If we take that out, if we add a specific constructor, then this one doesn't get auto-generated for us. The compiler will only add that default constructor if there's no constructor specified. So now what we've done is created what's called an overload. We have two versions of the bill constructor, one that takes these arguments and one that does not. So that means that we can now invoke this new, and we're using the parameter list constructor, and for these ones we're using the parameterized constructor. So that works perfectly fine. And if we go ahead and uncomment these two so that all four bills are added, and then if we run this again, we should see that our amount due per person is back up to $80, and we have all four bills represented. So lots of different ways of specifying things in C#, and that's really one of the big gotchas that C# has evolved to allow us to write things a lot faster. But that means as you're learning as a new programmer, there's a lot of weird ways of doing things, a lot of new ways of doing things. You don't have to use any of these new ways in class, but I want you to be familiar with them because you will see them in practice. So that's how you can use initializers. Another way we could do this is we could add a default value for these. So we could say the name is by default going to be an empty string, which by the way is what strings default to normally, and the amount due is going to be a default of 0M, so no amount due. If we do that, then we can actually create or call the constructor without any arguments, and it will use the default argument, and then this initializer will overwrite that. Which brings up another important point: how values are assigned in a class. For example, here we have the private name. We can apply a default value directly on a field. We can also apply a default value on an auto property like this, like datetime.now would be the bill is going to default to being due right now, whatever the current time is when this program runs. That will be the default value. That can be overridden with a setter by setting it at some point, or an initializer. And the order that these things happen is, first, anything that's declared in line as a default value, that's the first thing it's going to be set to. Then anything that's set in the constructor would overwrite that. So if it happens to change, like the name did in the constructor of some of these in our program, so the first two were setting the name in the constructor, that would overwrite that. And the third one is any initializer, so any initialization syntax is going to overwrite that value. And at that point, this variable has been initialized. So you actually have 3 points you can inject values in, and it will happen in that order. And let's see, let's go ahead and add the amount is 4 and due, and let's put our due date in here, bill dot due date. So we should see that these are all due today, and if we run this, we'll notice that no bill has that default value. So the water bill is for $30.40, cable and internet, electric and gas, so we've overwritten that initial value that was declared in the scope of the class, default value, and then they're all due today, the 24th of 2022. All right, so that's a lot of good kind of ideas. Now, the other thing we can do is we can make this program do some interesting things. Let's go ahead and date time.now gives us a date, and let's add days. Let's subtract, or let's add 18 days to that. So that's going to give us the current date. We're going to add 18 days. That's going to put 18 days on the end of the current date. So now it's going to be 18 days in the future. So most of our bill, or all of our bills, are going to be due in the future. Now we do have a setter. So I'm going to come back and manipulate one of these bills and say that the due date is going to be date.today.add days, subtract 2. So I'm going to make this bill late. So it's due now 2 days before now, or before when this program is run. And let's add another property to our bill. Let's add a late fee. So public string or double decimal late fee, and let's do a get and an init. So it's going to have an initializer, but not a constructor, or not a value private backing field. And then we're going to initialize that on, which one was that? The gas bill. We're going to say the gas bill is going to have a late fee. And we can combine this initialization syntax, by the way. So here we could say late fee equals, and let's say if we're late, it's just a flat $10 fee. So our gas bill should go up by 10, and of course there's no semicolon there. Or we could say, if you're more comfortable, we could say gas.late fee equals 10 M, like that. These are equivalent statements, so do whatever is most comfortable to you for now. Visual Studio is going to try to suggest that you use the simplification format. Oh, can't do that because we declared that to be an init, so it has to be an initializer syntax. It has to be. So my bad. So that is kind of the trade-off. That initializer gives us that extra level of control there, that it can only be at initialization time. So now, because our gas bill is late, we should have an extra $10 required for payment. And you can see gas bill is due 1/22, so it is late, but we're not actually applying that late penalty yet. So to do that, we go back to our bill and we look at this amount due. And our getter, we can add logic. We can ask the question, is this late? If the due date, and we're referring to this due date. This is optional, but it means this instance of this class, look at its due date, is that less than date time dot now. And that's basically checking if it happens to be the case that the due date was in the past, we're going to apply our late fee. So we're going to say amount due, return the amount due plus the late penalty. And since we don't have a private backing field for this, we're just going to use the getter for the property. And otherwise, return the amount due. And if you want, you can put those in curly braces. You can do them as one-liners. Also note, this else is not strictly required because this return statement, when we hit it, if we hit it, we'll actually exit this method and we'll never reach the next line. So the else is optional, but if you want it there for clarity, if you feel more comfortable with that, that's fine. So we go ahead and run this again. And notice that now our each roommate share has gone up by $2 because we're splitting that $10 across 5 roommates. So you can start seeing how there's a lot of different ways of writing classes and getting that information into them. We can do it with constructors, we can do it with initializers, but the important thing is we want to control how this class changes, and we want that to be done in well-defined ways. But it also means we can add a lot of extra logic, and here in our program, we don't need to worry about the logic for determining if we need to apply that due date. That's just handled directly by the class. So we've isolated that code in the class and we've abstracted it away. We don't need to worry how the amount due is actually generated. We just need to know that it has an amount due, and that's what we're going to charge for our roommates. So let's go ahead and add some class for our roommates, and we're just going to do a very, very simple class implementation because I'm not too worried about what those look like. And we've talked about all of these different ideas about properties and all of that. So we're going to make a public class roommates, or roommate, just one roommate, and rename this so that it is just roommate. Public string name gets and set, and and what I'm going to do here is a little bit of a tweak because we would want all of our roommates to pay the same amount. But let's say when you guys settled in your house, one roommate really wanted cable TV and nobody else wanted cable. They just wanted internet because they're using streaming services and don't feel the need for cable. But one person just insisted, and everybody said, well, okay, if you pay the part of the cable bill that is the cable, so maybe $25, then we will get cable. But you have to pay that extra $25 because you're the only one that wants that. So we can say, define that as an extra amount. So let's call this extra payment due, and we'll get a get and set. We'll go ahead and make it a setter so this can change over time if we renegotiate or something. But let's go ahead and add that in just so that we have that value available. So now if we go back to our program, we need to have roommates. So we're going to add another list, and this is going to be a list of roommates. And let's go ahead and use initializer syntax here. So initializer syntax with a collection like a list is a little bit different. And what it does is it allows us to construct items or drop items into the list. So the list starts out populated. So I'm going to start with a new roommate, and I'm going to use the initialization syntax, say name, and we're going to have Bob Dare, and we're not going to give Bob Dare an extra payment because he wasn't the person who wanted cable, and then we do a comma. So we can construct directly in the initializer. This is kind of a neat feature. New roommate, and this is going to be Mary Contraire. New roommate. Make this Zach Smith. And honestly, at this point, maybe we should have put roommate in the constructor, the name in the constructor, that would be fine too. In fact, let's do that for the last couple. Let's just keep it tight. So roommate. See, we had 5 total, so let's add Sue Smith, maybe Zach and Sue. No relation. Yeah, let's go there. And then one more. Mark Gata, and Mark was the roommate who insisted that they wanted cable, so the extra payment due for him is going to be that $25 that cable costs. Oh, and I think I declared it as double here. We want decimal. There we go. So change that. And now we have a list of roommates and a list of bills. And because we have a list of roommates, we no longer need the integer we had for number of roommates, because that's going to be determined from our list. So down here, we would say, instead of number of roommates, we just say roommates dot count. That's going to be however many roommates there are. Run this again. We should get the $80 per every roommate, or 82 because we're late on the one bill. But now we want to basically go through each of the roommate and tell what their amount is. So for each roommate in roommates, and I'm just going to go ahead and abbreviate roommate to RM. And it's okay to do that in these kind of loops where there's very little going on. And this is going to be the specific roommate's name now. So rm.name. And the reason I say it's okay to abbreviate here is because we can look right up there and see what it is. If this is only a couple lines of code, then an abbreviated variable name is okay. If it's a large block of code, it means somebody's going to have to scroll up or down to try to locate what that name is. It's usually better to actually spell it out like we did here with Bill to really give a good idea. So this is going to tell us each individual roommate's amount due. And between the two of these, I'm going to add one more console.writeLine, just so that we have an empty line dividing those two to make it easier to read. So we should have our list of bills, the water bill and the amount, the cable and electric and the gas bill. And notice that it did go up by that $10 because it was $140. And then we have everybody's share, and those are all equal shares. Okay, so how would we add in the logic for the extra payment due? Well, we could do it here in the program and basically subtract it, but now we're starting to add a lot of calculation logic again. What we would like to do is maybe put that logic in the roommate, because that's actually let's make one more class. Let's make a household or house class. And this is going to represent a household of roommates. Who share their bills. And we'll want to use a list here. So roommate, a list of roommates. And for right now, I'm just going to do that as a property with a getter and setter. And we'll do the same with bills. And then we can add a method for something like list bills. And this is basically going to take what we were doing here and dump it out. So we'll cut this and put it in here. Except we aren't going to do our total due there. And then void, because we're actually printing this console. And then we'll do public and make this capital bills so it matches up. List bills and list payments. I'll call it list payment roommate due amounts. Wonderful wordy answer there. And to do this, we need to basically do something very similar to this. So we're going to do the for each roommate. And that's in our household, our house class. And again, do the capital here. And we have to get that total due somehow, so we're going to actually do the same thing for each. Bill in bills, and double or decimal. And notice again, we don't need to worry about how that amount due is calculated. That's handled by our bill based on the current date. And then we can say the amount due here is going to be roommate count, but we could actually calculate that beforehand. And we could even reuse the amount due, or probably better to declare a new one, decimal, just for clarity. And set that equal to amount due divided by the roommate count. Roommates.length, our count. And that would be what we'd put in here, roommate amount due. So what each individual roommate owes. However, we want to take this amount due and we still want to reduce it by extra payment. So and I am going to reuse this. So because I got a comment in here and it's pretty clear what we're doing, we can actually simplify this, and actually this is a good opportunity to use. You've probably used plus equals a lot. You've probably never used divide equals, but it means the same thing. It means take the current amount due divided by the roommate count and assign that back to amount due. So that is now going to be the amount due per each roommate. And then we also need to remove from that amount due any amount that somebody is wholly responsible for. So we basically have to iterate through our roommates again. And we can pull out amount due minus equals roommate dot extra payment due. So whoops, we don't want to do that there. We want to do, because that's going to do it to that pre-calculated one. So we're going to move these around. Any extra payment a single roommate is responsible for. So here we're calculating the amount due for all bills. We're removing any extra amount that a single roommate is responsible for. Then we're calculating the base amount per roommate, so that is that reduced amount due by the roommate count. And then we're going to print the amount due each roommate. And this is going to be then the amount due plus the roommate's extra payment due. So if any roommate has an extra payment they're supposed to give, that's going to get added directly onto their amount. So it's removed from the total that we're averaging and thrown on the end. So the nice thing about doing this is this is not hugely complex. It's pretty easy to walk through this function and understand what it's doing. But then here at the program level, now all we have to do is, instead of putting these directly into how we're doing it, let's do create our bills and all that information. When we get to here, let's go put all of those into our house. So bills and roommates. Need both M's. So after we've initialized those, we can just drop them in the house object, and then we can say to the house.list bills, do our extra right line, and then house.list roommate due amounts. So once we have our household set up and we have the bills entered, this is really all it takes to print that out. Let's take a look at what that looks like. So we have our bills, and again we're doing the extra late payment on the gas bill. And notice everybody's share dropped a bit because Mark Gata has to pay that extra $25 for the cable. All of these still add up to the total amount due, so as long as everybody pays their share, you've covered all the bills. And the real reason we start writing programs like this is this allows us to really kind of abstract away some of the complexities of the logic, package it into an encapsulated class, like the bill, like the house, like the roommate, and then we don't have to do nearly as much juggling of ideas in our heads. It becomes much easier to write, and then also much easier to test, which we're going to talk about down the line, where we go through and make sure that each one of these functions exactly the way we expected it to. So that is what we're going to cover. That's all we're going to cover today for how to actually work with classes and how to effectively use them. I want you to remember some of the ideas like properties. We use properties extensively. In fact, there's really almost no time that you'd want a public field in a class. It just shouldn't happen anymore in C#. If it's public, it should be a property or a method. And a property itself is technically just two methods or three methods potentially, an init, a set, or a get, so that you can use those in different combinations. You still use them like a field, but now you've got that extra layer of protection where you can control exactly how things are set or updated and when they can be set and updated. So that gives you a lot of extra control and helps really protect the data in your class from being mutated unexpectedly. That's it for today. So go ahead and finish off your project, build a release, turn it in for this, and we'll see you soon.